Neil deGrasse Tyson passionately shares that the most disappointing and heartbreaking discovery by Voyager in the previous decade is a finding that scientists were not prepared for. The probe sent back troubling information from space, causing experts' agitation and everyone else's anxious mood. Analysts and scientists have been deviating from their typical tasks to investigate these mysterious objects that Voyager just detected. "We have no idea where these strange things are, where they came from, or where they're going, but we know for sure that we've never before seen anything like them," Tyson stated. "What are these puzzling items found by Pioneer 1? Join us as we explore the responses to Neil deGrasse Tyson's claims about Pioneer 1, which has identified 500 dark objects moving through space. For nearly 50 years, Voyager 1 has been traveling through space, exploring areas that Earth-based telescopes can't reach, and revealing astonishing discoveries that leave us speechless. Voyager has transformed into the center of new regions, in the space between stars. This engineering marvel has opened our eyes to the marvels of the universe. Neil deGrasse Tyson recently confirmed that Pioneer has identified 500 floating dark objects silently in space. The news was shocking to many scientists, sparking a frenzy as everyone started looking at the data collected by Pioneer 1. Something unusual was happening, and experts struggled to understand this surprising finding. Various theories began circulating, as researchers attempted to piece together the mystery. If another rocket had returned this baffling data, its accuracy might have been questioned by researchers. However, we're talking about Pioneer 1, a space probe that has been exploring space's vastness for nearly 50 years and has surpassed our expectations. Similar to a patient who has overcome an illness, Voyager 1 has surpassed the scientists' initial expectation of a 3-year mission, having spent more than 45 years in space and making revolutionary discoveries. The most fascinating aspect of the story is that Pioneer is revealing this amazing journey from a distance of billions of miles. The last time Voyager was examined by researchers, it was 14.5 billion miles from Earth, continuing its traversal of space without any sign of slowing down. Researchers report that the space probe travels at a speed that covers the distance between the Earth and the Sun many times each year. This is a fact that is hard for scientists to accept, considering that one would expect the speed of the probe to have significantly decreased after so many years. However, it seems that Voyager 1 is an exception, and its recent discoveries support this. It seemed like an ordinary day for scientists when Voyager 1 sent exciting news that would be long remembered. The probe accidentally discovered some unusual objects passing through space. It was shocking to learn this, explaining the initial miscommunication between cosmologists when they found data showing around 500 dark objects appearing without a trace. In an instant, we went from having no information about these things to experts rushing to find answers to this puzzle presented by nature. Scientists were in a dilemma, and there was only one party to blame: Pioneer 1. Suddenly, researchers knew that finding the answers lay heavily on the space probe's shoulders. When word of this discovery broke, some scientists speculated that it could be a mistake. Voyager, they thought, might have erroneously identified these items and sent back incorrect data. If we follow this line of thought, it seems like a plausible explanation, particularly considering Voyager 1 was launched back in 1977 after nearly 50 years of continuous service for humanity. One might expect that the computers would have become obsolete and started to fail, sending back low-quality information to the ground team. As interesting as this theory is, scientists have cautioned against jumping to conclusions, as it would undermine the probe's achievements. Despite the harsh and unpredictable environment of space, Voyager 1 has consistently sent back valuable data about our universe. Despite the skeptics, the probe has lasted so long due to its dual redundant computer systems. Like its twin, Voyager 2, Voyager 1 was provided with 2 sets of systems, one for executing commands and processing data, and another for control systems. This redundancy has been the secret behind the probe's unwavering enthusiasm for exploring space and making discoveries. This built-in redundancy permitted perpetual switching among systems and the capacity to use and activate computer parts, prolonging their lifespan. When engineers on Earth who worked on Voyager 1 developed strategies for maximizing the efficiency of the spacecraft, this meant that the instruments of the probe had to be built using simplified systems to meet time constraints and power limitations. Electrical engineers concluded that the instruments should be easy-to-use systems based on the logic of hardware. As a result, Voyager's computer systems include power administration, with 6 onboard computers organized as a distributed system with 3 dual redundant pairs. Having overcome this challenge, scientists had to face the next big task, which was to keep the systems running. They reacted to this problem by establishing a power management plan. Here's where it gets interesting. Power management involved supporting the functioning components of Voyager's computer systems. This was a challenging task, given the limited power resources on board the spacecraft. However, experts devised a strategy to monitor and optimize the use of power. One real instance of these energy management strategies is the scheduled shutdown of non-essential systems. Researchers faced a difficult choice and employed a meticulous method of identifying and deactivating subsystems or components that were not vital for the probe's primary mission objectives. This is evident when investigating the radiators connected to certain instruments that had to be turned off. These radiators were initially intended to keep the instruments at specific temperatures for optimal function. However, the method was adjusted to activate them only when required to significantly cut down on the energy use of the spacecraft's resources. This reduction in energy use creates a ripple effect. It prolongs the probe's operational life. It's a reciprocally advantageous scenario. Emphasize that the decision to power down non-essential systems wasn't made lightly. A move like this requires careful evaluation of the compromises between conserving energy and fulfilling the spacecraft's scientific aims. The entire team had to make the decision. Work together to determine the impact of putting some of the systems on the quality and availability of scientific data. Emotions were set aside. It was only focusing on the current facts. The team endeavored to improve energy efficiency while ensuring the spacecraft could keep gathering vital information about our universe. Both engineers and scientists insisted that no obstacle should prevent Voyager 1 from uncovering the profound secrets that lie beyond the reach of space. The universe's hidden secrets have been under guard for years. Additionally, power reduction isn't the only strategy NASA specialists are employing to keep Voyager's operation in space. They also had a significant additional advantage to support the probe. The team devised plans for managing energy that were tailored to the constantly changing conditions of the surroundings of the probe. For example, as Voyager 1 travels further from the Sun, the available solar energy diminishes. This presents a difficulty. However, the experts were ready. They compensated for this declining energy by ensuring the spacecraft adjusted its consumption of energy accordingly. This adaptable approach is advantageous for scientists and engineers from NASA. It assures that the available energy resources are well distributed to support the crucial tasks of the probe and data transmission back to Earth. The good news doesn't end there. Ongoing updates and improvements to the technology in energy management 40 have allowed engineers to improve the power system of the spacecraft over the years. A closer examination of these upgrades reveals that they include more effective distribution of energy, improved battery charging techniques, and advancements in energy regulation and control. The careful planning and management of energy resources have empowered Voyager 1 and its sibling, Voyager 2, to continue its investigation of the universe. The announcement sent waves through the community of scientists. Neil deGrasse Tyson's announcement resonated worldwide, highlighting an entire decade of Voyager 1 conducting a thorough investigation in the vastness of interstellar space. The investigation had unexpectedly revealed an anomaly: 500 mysterious objects, their origins, and purposes concealed in deep secrecy. Silently moving through the void, this startling discovery ignited a wave of scientific inquiry. researchers and scientists around the world began collaborating to understand these strange things, trying to find their origins and purposes. The significant finding by Voyager 1 opened a new chapter in space exploration, challenging existing theories and inspiring fresh ideas about cosmic enigmas. The ongoing analysis of this data has the potential to expand our comprehension, possibly revealing insights into the nature of the universe and our place within it. As we continue to investigate the mystery, the ultimate goal remains to uncover the truth behind these dark objects and their implications for our comprehension of space. As researchers delve deeper into the 500 dark objects identified by Voyager 1, the scope of exploration has expanded. The initial information gathered by the probe has already sparked several fascinating theories. One hypothesis suggests these objects could be remnants of ancient astronomical occurrences like debris from exploded stars or fragmented asteroids. Alternatively, they might consist of materials currently unknown to science, hinting at new forms of matter or entirely new physical phenomena. Astrophysicists are employing advanced computer models to replicate the trajectories and possible origins of these objects. By analyzing their movements and speeds, researchers hope to determine if they originate from a common source or if they emerged from various distinct events. This aspect of understanding depends on the study of the broader implications of the discovery, such as the potential existence of previously unnoticed cosmic cycles or interactions. Observatories worldwide have worked together to track these objects. Ground-based telescopes are being utilized to verify and augment the information returned by Voyager 1, which offers a more comprehensive view of their properties. Imaging with high resolution and spectral analysis are key components of this work, aiming to identify any chemical signatures or physical characteristics that might let us know more about their nature. In addition to observational initiatives, theoretical physicists are exploring the potential effects of these discoveries on our understanding of fundamental physics. If the objects exhibit unusual effects of gravity or electromagnetic properties, they could offer insights into theories of dark matter or dark energy. Such findings could reshape our understanding of the most mysterious aspects of the universe. The discovery has also ignited collaboration across various fields. Cosmologists, physicists, and even materials science experts are contributing their knowledge to solve the enigma posed by these unknown objects. This cooperation encourages a more complete understanding of the data and ensures that all potential angles are explored. As a result of the public's interest and scientific enthusiasm, NASA has begun releasing periodic updates and findings in connection with the ongoing investigation. The purpose of these reports is to promote transparency and stimulate educational initiatives that engage students and enthusiasts in the scientific process. Looking ahead, Voyager 1's journey and the 500 mysterious dark objects will likely remain a central focus in astrophysics. With continued observation, theoretical analysis, and global collaboration, scientists hope to solve one of space's most intriguing mysteries.